Hi, I'm Grant Pacheco, and this is the Black Bayou Microcosm Project. Heads up, for my microcosm overview, I'm going to read aloud everything that I wrote down, and then I'm going to go into a little bit more detail about each thing. As you can see, there's a picture of me right there. I'm collecting my specimen and microcosm specifically from Black Bayou, which is a local park by my home. So, I will now read from the text. I took on this microcosm project with an open mind and hopes of greatness, as it has been a long time since my last science project. I took on this project with the hopes to have a successful and healthy microcosm. I wanted to see if this was able to be done, understanding an environment by creating my own without direct influence from other organisms and natural elements. As this project has progressed, I can see why the use of microcosms are helpful because of the fact we can examine a specific ecosystem right from our very home. What must be understood from the presentation is that I tried to be on target with my measurements when first creating my microcosm, and I believed if I followed exact instructions for this project, I would be successful. So all that being said, um, obviously it's been a long time since I have done anything like this, and I wanted to make sure that I was exact. So when I read through the instructions, I wanted to make sure that I got everything correct because I had a feeling that maybe some of my other classmates would have just kind of just dunked the jar, fill it up with water and sediment and stuff like that, whereas I felt there was going to be a need for oxygen, and hence why I put such a particular point to wanting to make sure that I had the exact right sediment. I didn't want to put too much water in there or too much of the vegetation because I felt like it might overpower the jar in and of itself. So I just wanted to make sure that was going to be the most successful I could make it. And we'll move on to the next slide. This is my hypothesis is that although I've collected the correct measurements of my microcosm, it will stay healthy, but the water level will decrease as the source for a healthy environment are limited to what is exactly within the jar. So what that basically means is I understood in this assignment because I saw the phrasing of how could you add to something without being able to actually take off the lid and touch it. And with that being said, I wanted to make sure the best bet I thought I could do was going to be how much sunlight, excuse me, my microcosm got. And I wanted to make sure that it wasn't going to be too much. I live in Louisiana and I know that the temperatures can be pretty extreme out here. For example, today it's supposed to be a high of 104. And that being said, everything trapped within that microcosm is not going to be replenished. The best thing to do is just try to make it to last as long as it possibly can. And I think that we did that pretty well throughout the project. However, like I said, I was expecting the water level to decrease as well as some of the vegetation within my microcosm to end up failing. Um, I'll move on to the next slide now. All right, methods and materials. So when selecting an area from where to collect resources for this microcosm project, I decided to go back to my local park from the Black Bayou Park in Louisiana. For the collection process, I took an empty pasta jar that I had only rinsed and dried until clean from any remaining sauce. I then filled the jar with about half a cup of sand from the beach. I then filled the jar about halfway of the water from the source to not overfill the microcosm and leave room for oxygen. I then took two samples of plant life, the difference being the plant life sitting on top of the water and then under the water, to provide some variation within that microcosm. This project ran for around 7 weeks, and where it stayed within my windowsill, absorbing major sunlight for around 6 hours every day. So once again, as I mentioned before, you can see based on the picture, that's exactly where I drew from. So as you can see, there's some plant life under the water. I did take some of that, and then I also plucked from the plant life sitting on top of the water. The sediment was fairly easy. I just took a measuring cup and just scooped it out from there. A funny story about this collection process is as I was going through the collection process, a family was swimming there and they came up and approached me and asked me if it was okay if their kids were safe to swim there because they were like, "Why are you testing the water?" And I found that to be pretty funny, and I had to explain, "No, no, I'm just doing a science project for my schoolwork." Um, Little tangent there, but anyway. Um, and then as you can see from the collection process, as I wanted to make sure on top of that, I didn't want to use soap in the event that any residue might stay from there. I just wanted to use water and then just hand dry it to the best of its ability to not mess with anything within um, my microcosm altogether. And as I stated before, I wanted to make sure there was enough room for oxygen as far as the water. Upon collecting everything, I wish I was a bit more on point when it came to actually pouring the sediment in there. So before I even, I should waited a little bit, waited for that sediment to settle, and then maybe level it out a bit. Because there's one thing I noticed about my microcosm is that there was kind of like a divot and a depth to it from where I just poured everything in, so one side was a little bit higher than the other. Not that I feel like that really changed the microcosm altogether. I think it would just be more aesthetically pleasing had I, took some time and made sure everything was level before proceeding with the rest of the project. All right, and then that being said, we're going to move on to the next slide. Okay, so weeks 1 through 3. I'm sorry for my awful sketches. I'll just say that beforehand. I'm currently active duty, and I was having some hard times finding the time to get some pictures. So you'll see these horrible sketches from weeks 2 through 4, but I did the best I could when trying to take some pictures. That being said, we're gonna go through the week by week, and we're just gonna go into a little bit more detail about specifically what I had seen. So, the microcosm was collected on this date, and the sediment has not yet settled, but I was able to see I did in fact have heterotrophs within the microcosm. I was hoping by leaving space within the microcosm, I would be able to have this experiment last longer and stay healthy. So, as I kept an eye on it on the first week, and I did see I saw some moving particles in there, which turned out to be the actual organisms. I could see that they had appendages and things to that nature. Once the settlement finally kind of settled down, I was able to get a good look at it, and they were transparent, and I was just happy to see. I didn't think I would have any organisms actually floating around in my microcosm, so I was very happy to see that I did in fact have something in there, and it made me feel like I really wanted to take this project seriously. The fact that there was those organisms within my microcosm. So I wanted to make sure I did this to the best of my ability. All right. So week 2, the coloration of the autotrophs and heterotrophs are healthy and strong, and the sediment has settled and the water looks clear. So at this point with week 2, nothing had truly changed aside from that the water had cleared up a little bit. The sediment had settled, and obviously everything was looking fairly good. I couldn't really complain at all. And let's see here. So then on week 3, by this week, the water level had begun to lower and algae had begun to form on top of the sediment. However, the coloration had remained the same with water and plants, and the heterotrophs are still alive within the microcosm. So everything was good. However, I was correct. This is where I already started seeing, I knew that the sun was going to be a lot for the microcosm, and of course it was. We got to see that all the way in week 3. So we saw the water level go down, and then we saw algae start to form on top of the sediment. Uh, and from there, I mean, everything else kind of just goes according to plan, and we'll see that through weeks 4 through 7. So we're going to look at that right now. Okay, so weeks 4 through 7. I have found within this week that the plant life within the microcosm has started to turn brown. However, everything else is currently the same. So the only thing that I had seen, water level, did stay the same for this week. However, I did see, not specifically on the stem, but rather on the leaves for the plant life that I had within there was starting to turn brown. If I had to guess, you know, the resources were starting to be utilized, and from there, it started dying. Now, I will say throughout as we go through these notes, you will find out that everything turned over really great. It stayed green. I didn't have anything else spread from this point, but week 4 was the point where we started losing leaves and things to that nature. So week 5, the dying plant life has stayed the same and not changed in any way. The rest of the microcosm has stayed the same within this time. From here, there wasn't too much of a change. A pretty boring week overall, you could say. And actually, in this week is the week I was also in St. Louis, so my wife was able to give me that lovely photo that you see there. So week 6, the major change this week was the number of algae that had settled on the bottom, and the water is now green. So this was one thing when I came back and I got it to get a good look at my microcosm after returning from training. I saw that there was quite a big change. Just with the amount of algae that was forming on top of the sediment, it kind of blew me away with just how full my sediment had grown. That was not something I had anticipated, um, or the water itself. It turned into a shade of green, but I think that comes with time, and as you know, there's not any new water sources and it's all confined to one specific area, I think it makes sense that things like this would occur. So week 7, the final week of the review, has shown an overall healthy microcosm and still great signs of life. And I do agree with that. Granted, I don't know how much longer, if we were to continue this project, how much longer this microcosm would survive on its own without being touched or sealed. But I am overall happy with the health because was still able to see that the autotrophs and heterotrophs were all still looking very healthy and still had movement, and that really made me feel good about myself that I was able to do this experiment. It's scary, when you get a project and it's like, hey, you're gonna get this and you are not going to touch it again. Essentially, the only variable you have is the location that you set it in, how much you want to dictate, how much sunlight is the microcosm getting, how much is it not getting, the temperature that it's stored at, and I was just happy to be able to get through it and make sure everything looked okay and nice and healthy. And now we'll move on to the next slide. So my major findings, as I predicted, I found that my microcosm, after amount of time, I would appear that the autotrophs have been utilized by the heterotrophs, and because of this, the water level has decreased and parts of the plant life started to become brown. I was unable to create additional avenues for the microcosm to be self-sustaining. I am sure over the time the microcosm would use all of its resources and eventually fail. However, for the week 7 process, I was able to be successful enough to complete the project, as I am happy to say even within the last week my heterotrophs are still healthy and moving freely. So, like I said, to create something that was self-sustaining, I think that it would require some additional research on top of that, maybe even a bigger vessel to store within the for that microcosm. And if I had to guess, it would probably require more plant life, things that actually feed better off of each other. But for a simple project like this, where we were able to just work through it, I think everything turned out pretty well. My hypothesis was correct that the water level is going to change, resources are going to be utilized. The microcosm is not going to be self-sustaining permanently. Over time, everything eventually dies, and I think we saw that here, and we did a pretty good job of being able to document that. So now that we went through the major findings, we're going to move on to the conclusions. Okay, so for the conclusions, we wanted to go over 3 concepts that I found within my project. So solar radiation, this drives the climate and gives energy to plant life on this earth. The only true outside variable within my experience was how sunny it was, as this affected how much direct sunlight my microcosm took. And I felt like solar radiation was very important specifically for this project because, as I stated before, you are able to move the microcosm right, but I felt like this was something where if I was to, this being my first shot at it, there is certain things I could do. I saw other classmates throughout discussion boards. They were mentioning, hey, we're looking at, I set it to this specific temperature, specifically to this windsill, so I would get this many hours of sunlight, which I did go back and in my microcosm log, I did look at how many hours of sunlight and then how much of that was peak sunlight hours. But because that is such a big variable to the success of the microcosm, I felt like that was something that thrived in and particularly pertained to me. So the next concept we're going to go over is the populations, which is a specified group of one species. In this case, with my microcosm, I couldn't identify the heterotrophs that were within the microcosm, but when I did spot them, they were all the same population. So, and to go based on that, from what I saw, they all looked exactly the same. They were transparent. They all looked in the same format and size and shape. And I could say the same thing about the plant life within there because there was only so few variables. Um, well, that does link into my next concept, which is the ecosystem, the biology of a community that affects itself by its surrounding environment. This is played as a crucial role in this project, as the microcosm itself was an ecosystem itself. And I stand by that. You know, really, when I was at work, I was telling, some of the people I work with, I was like, oh, yeah, I'm like creating my own ecosystem. And I thought that was really important and cool. The fact that I was taking care of something. Like this was my world. Although I, you know, took it from something like the Black Bayou Park, um, this was something that I was in charge of, something that I needed to keep specifically to myself, that I was in control of this. It was up to me if this thing was going to be successful or not. I could have easily just put this thing in my office where it wasn't going to get any sunlight. I mean, I could have just left this thing outside for 7 weeks and just been like, oh, you know, have at it. We'll see what happens. But I didn't want to do that. I wanted to do this in a controlled environment where I could be successful and something that I could be proud of, that something I can say that I did. And I think we did that really well here. So the microcosms can be important for the overall ecology, as this can be used to see how specific autotrophs and heterotrophs are affected in certain conditions. Not only that, but we could see how, excuse me, how maybe non-native organisms could coexist within one another, and what conditions would be ideal for all parties to grow healthy. So, what this is in reference to is why are microcosms important for ecology? And I think a good reason on why it is as stated there, is this is something that you can do from your home. Not only that, but this is something that you could do from all walks of life. If you don't want to do it from home, you can do it for labs. But you can see and create your own ecosystems, right? Because you could go out somewhere every single day and you could monitor something. But this, you could have constant 24/7 supervision if you wanted to. Not only that, but as I mentioned, if you wanted to see in a microcosm, you could create one. Say you have an entire ecosystem that's used to itself. You gather all plant life from there, everything like that. And if you wanted to travel and then add some kind of outside non-native organism to that microcosm and see if it could coexist peacefully, and see if it would actually grow or not, you could see specifically what kind of organisms from here on out would actually work within a certain kind of ecosystem. So that being said, my conclusion is my hypothesis was correct. That microcosms can be extremely important for ecology, and yeah, I'm very proud of this. And we will move on to the next slide. The research. A further hypothesis I would like to get further clarification on would be if I had filled the max volume of my microcosm, would this have created problems for my autotrophs and heterotrophs? I think that that's important because there was one thing that I noticed when I was looking at some of the classmates that I have when we were posting on our discussion board for, I think it was about week 6. We were kind of giving an update on how everything was going. And from there, what we saw was I saw that a lot of my classmates had some full volume with the water and things to that nature. And I saw that their microcosms were like turning black, or they overall I didn't feel like they looked as healthy as mine. Not tooting my own horn or anything like that, but I was just curious if that was a oxygen issue, if that could have been vegetation that was put within the microcosm, that could have been variables like how was the microcosm stored, things to that nature. I thought would be very interesting to kind of see how much is oxygen playing an important role within that microcosm, like giving it that space. All right, and then the next time, to further improve this microcosm, I would have done further research in the beginning to see how others have had success. More specifically, with how hot Louisiana can be, I am curious if I kept my microcosm at a cooler temperature, if my microcosm would be more successful. Uh, so that being said, I didn't do any research before doing all this. I kind of just took it as once I got the measurements, this is going to be my best bet. And from there, I just kind of came up with some thoughts in my head like, oh, I want to make sure I'm going to do direct measurements. I want to leave enough space for everything. I don't want to overfill the microcosm itself. I thought that could be a bad idea just because everything is eating up more oxygen that way. So I thought that almost like a minimalist ideal was going to be the best case for this microcosm to be successful. And then, as I've mentioned before, variables such as like keeping things at cooler temperatures and specifically monitoring the amount of sunlight that the microcosm itself gets, I wonder if that could improve the overall success of the microcosm. And after that, we'll go to the references page. This is my references page where I just kind of looked up uh, ideas. As you can see, these are some good sources that I got on why microcosm studies are relevant to general ecology. So I took ideas from that, and then also just beliefs that I had that I thought were going to really help in comparison to the microcosm ecology itself. And as well, I got some definitions as I needed that specifically for the concepts of those three concepts that we went over. But that is my presentation. Thank you guys so much, and I really appreciate everything. I hope you guys have a wonderful day. Thank you.